Welcome to Proteins and Enzymes Part 11. We'll look a little more closely at those enzyme cofactors. And let's get started. Alrighty. So now linguistically there are some inconsistencies as we look at different textbooks and different people we talk with. So I'll sort this out as best I can for you. So enzyme cofactors, right? So that's a very broad term, and it describes conjugated proteins that require non-protein portions as cofactors, right? So enzymes that need cofactors. So when we think about the enzyme, right, that's the protein part. So these cofactors are non-protein portions. So cofactors come in two flavors. They can be metal ions. And what I've observed is when I read from different sources, cofactor seems to be the term that goes with the metal ions that are used as part of an enzyme to catalyze reactions. And then coenzyme gets used as the term for non-protein organic molecules. All right. So the convention that we'll use is when we're referring to a metal ion, we'll describe it as the cofactor. And we're looking at an organic molecule, we'll call it the coenzyme. So an example, zinc, right? We talk about zinc is important for our immunity and health, and it's an important cofactor in several enzymes. And so here's one example here, Carboxy Peptidase or peptidase is an enzyme that requires the zinc ion as a cofactor. This enzyme hydrolyzes the first amide bond at the C-terminal end of peptides, and it's secreted or it's synthesized in the pancreas, and we use it in our small intestine. And so the main thing here is the zinc, right? So the zinc is the cofactor. And so this looks very confusing and messy. And then if we look here, we have scientists have come in and we've investigated and we've learned more about the structure. And then we can see those carboxy groups, right? We talk about the C-terminus here. And we can see how the C-terminus will be the anions, and that will be electrostatically attracted to the positive charge of the zinc. So we can see how the metals, through their electrostatic interactions, can help to secure a substrate to the active site of an enzyme. All right? So with the cofactors here, right, we think about it's an electrostatic interaction, right, to attract substrates to active sites. Alrighty. Okay, so that's really, there's not a lot to know, but they're important, so it's worth taking some time to talk about it. And now we'll look a little more closely at the coenzymes, the non-protein organic molecules that an enzyme may need to catalyze reactions. All right, so NAD plus to NADH is a very important coenzyme pair. And we see them a lot. So here's lactate. We see lactate dehydrogenase to pyruvate. And so if we look here, we look for a change, and we see that there's a change in this portion of the molecule. We see that our secondary alcohol is being oxidized, all right, to a ketone. All right, and we look a little more closely, and then we look at our coenzyme, and we see that it is gaining hydrogen, right? So it's being reduced. Okay, So, which species has been reduced? That would be the NAD+. And which species has been oxidized? That would be the lactic acid. Okay. Now, it's important when we're looking at biochemical reactions to remember that the enzymes catalyze both the forward and the reverse processes. So sometimes you want to look at a reaction backwards. Alrighty. So if we look right here, we look for the change, right? And so now we're going in the reverse, right? So now we have the reverse reaction of above. We see the pyruvate there, and the ketone of the pyruvate, right, is now being, right, reduced, right? So the ketone is being reduced to an alcohol. And so conversely then, right, we look at our coenzyme, what's happening to our coenzyme? Our coenzyme is undergoing oxidation. So, right, so the main point here was to just keep our minds open that the reactions can happen both forwards or backwards depending on what's going on within our body and what the needs are. And so the coenzymes are there to, in whichever form is needed, to support the oxidation reduction reaction. Alrighty, so that wraps up this brief overview of coenzymes and cofactors, remembering that the cofactor term we'll use for the metals and the coenzyme we'll use for the organic molecules that are not proteins. Please take some time now to work a few homework problems to reinforce your understanding.